Hello friends, so we'll do the quick revision for the cloud service lifecycle. Hello friends, so we'll do the quick revision for the cloud service lifecycle management that we had seen. Next, so the in the whole lecture series we had already seen cloud lifecycle, cloud deployment scenarios, cloud service development and testings, then web service regression testing and slicing. So these are the content that we had seen. Then cloud service evolution analytics we had seen. SLA and QoS things we had seen. This was the so sorry. Actually there was some voice in between, so I have to remove that for the sorry. This was the first research paper that we had seen for the cloud life cycle. So they defined cloud life cycle in terms of service analysis, service design, and also the service implementation, then service publishing, service operations, and then they had defined in terms of service operation and retirement. So these are the main evolving part of service life cycle. And then they had integrated actually the services with the fundamental management phases, and then they explained this uh, both the things, service life cycle and generic management phases. We had seen another model for cloud service lifecycle. For example, the requirement required for the maintaining service, then discovery of the web service, then negotiation of SLA and QoS for monitoring purpose, and then compositioning of various services together that provides actually services for cloud to the consumer. So they had basically divided into five different parts: requirement, discovery, negotiation, compositioning, and consumption. And each phases are being represented. We had seen NIST IT standard for life cycle. So this is general IT standard life cycle for cloud computing. So there's simple as general software engineering standard for IT operations like requirement basis standard, profile development, referencing product services tools, testing, and then deployment. So these are the basic. And next we had seen cloud deployment scenarios. What are the cloud deployment scenarios we have seen? So we have seen the single cloud system, multi cloud systems, either with one time serial and simultaneously working one time. Then we have different kind of scenarios we had seen for these three type of systems. Then we have seen dividing of centralized and distributed use cases for the high level scenarios, four cases for the deployment within the boundary, across the trusted boundary for the centralized and distributed cloud. These are the four cases basically we had studied, where each consumer, each cloud type of things were there for the based upon divided upon the cloud provider and cloud consumer, how they interact with each other. So they are being further divided into the subcategory. So these are the scenario and the technical requirement for the maintaining the deployment. These are the 10 important scenarios and technical requirement that we had discussed overall. Next, we had seen cloud service development and testing frameworks. So first, we had seen a large tool and integrated development in the environment, which is NetBeans for web service deployment and development purpose. So these are the standard which are being used for web service development. Then SOAP-based web service development we had seen. So RESTful based web service development we had seen for the NetBeans. This is we have seen NetBeans web service client, how these are being managed. Then these are the detailed features for the web service client provided by NetBeans. Eclipse web service tool management we had seen. So Eclipse web service tool is a project of a web service integrated development environment, and it supports Apache Access and Tomcat like server for maintaining the web service features. NetBeans supports Glassface in Tomcat. Then we had seen web service tools, web service components, various components, and which were being developed developed by the Eclipse project. And in next we had seen Apache JMeter testing framework, where we had seen how the load testing, performance, and web application static analysis, dynamic analysis for resources. This tool helps in all these things, means simulating heavy load for the server and having extracted HTML, JSON, XML, textual format. So this is very large framework, and we just need to focus on the SOAP and REST web service for if we want to use JMeter for the cloud testing. This was the main feature, SOAP and RESTful web service analysis. And all these things, web, FTP, LDAP, database, all these things are used in cloud maintenance, but SOAP and REST is the most important part for cloud purpose. Then these are the important features of JMeter for the cloud computing. So like web, SOAP, RESTful web service, load, test, functional behavior. Next, the JMeter web service plan. So this was the how the framework for the SOAP based testing or RESTful based testing takes place. We had already seen. Then SOAP UI testing framework helps in doing different kind of testing. So we had also seen SOAP UI based testing framework. It is an open source. Both JMeter, all four are open source. NetBeans, Eclipse, Apache JMeter, and SoapUI. And they SoapUI do RESTful and SoapUI SOAP API testing. And then we had seen the type of testing it supports, like scriptless functional testing, security, load, API mocking, protocol supports, and all the all these things were being done with the open source community. Then we have seen the testing framework for the for example of calculator web service. Request and response we had seen, means for adding two digits. Uh, and then we have seen how RESTful API could be tested. It is also been supported by SOAP UI. So this was the simple feature for doing testing. And additionally, we had also seen the hierarchy for test suite test cases contains test steps. Next, we had seen web service slicing for the regression testing of web services based upon intra and inter-operational analysis, where we had seen introduction, proposed definitions, the the main part for introductions, like we will deal with abstract interface and atomic unit like operations. Issues that are being addressed are like operational analysis, program slicing, and regression testing of large web service. Then contribution basically of this paper was like web service slicing, interface slicing, intra-operational analysis, inter-operational analysis, associative code test mapping, operationalized regression testing of web service, parameterized regression testing of web service. Then here we had defined intra-operational analysis, inter-operational analysis, subset service, various definitions for web service slicing, interoperable slice, interface slice we had seen. We had seen an example for banking web service for having interface slice and interoperable slice. We had also seen definitions and the introduction for the interoperational changes captured by difference WSDL, unit WSDL, and reduced WSDL, combined WSDL. And we had seen inter-operational change analysis based upon the inter-operational changes where parameter WSDL and it's analogous to the database is analogous to the web service operations. How we had chosen primary keys uh, which were similar to the database concept. We had choose primary parameters for web service operations. This was being described. Then this was the basic flow chart for the regression testing of web services. First, we do intra-operational change analysis and inter-operational change analysis for construction of different WSDL and do the associative code test mapping for generating the two different type of test suites. Then these are the case studies at different level for the insertion, deletion, and modification of WSDL or web service code changes and the test case template analysis. Then we have also seen the framework for the operationalized regression testing of web service. An example for such thing, we had seen parameterized regression testing of web service flowchart, how this has been done by using var file means archive, which is executable or source code for generating call graphs for containing inter-operational dependency for inter-operational analysis. Then again did associative code test mapping for generating reduced regression test suite. This was the example that we had seen for the PRTWS. This was the AWS tool which do all these things. Then we have seen case study for white box analysis, black box analysis based upon these web services project. We had seen detailed results for the subset WSDL and test cases. Then these are the black box interoperational analysis web services being used for choosing primary parameter and non-primary parameter. And this was the example for the test suite of SOAP UI for doing testing of web services. Then these are the basically operation for the Bible or book web service. And this was the call graph. This call graph looks like this for the large web service. And this is having like different operations communicating with different procedure and method which were being analyzed for doing reduced regression testing. Then the observations like better change analysis, better capturing of subset WSDL for relevant task case selection, and interface slicing, interoperable slicing, associative test code mapping were helpful. Then awesome testing framework, reduce regression test suite generation, subset generation. Then we summarize this research paper in terms of web service slicing and web service interoperability for subset service, and intra-operational analysis and interoperational analysis. Then doing subset service analysis for doing regression test suite analysis. And this was been successful for reduction in regression testing efforts. So these were the resources that we had seen, other related papers we had seen. Then next paper like cloud service evolution analytics. So how this cloud service evolution analytics was being done in written in this research paper. We first introduced what are distributed computing, what are the type of distributed computing, and basically changeability and evolvability we'll study in change mining and evolution mining we had studied. Then different versions of an evolving distributed system. Then we had seen an algorithm for doing service change classification, which is having different steps for doing service change classification and then construction of a WSDL slice. So these are the different level of changes happens, and cloud service change analysis being defined at different level of WSDL, and these were the changes captured in the parts of the WSDL, and this was the example for the change of service version 1 to the version 2. Then we have seen the service change classifier algorithm and web service WSDL slicing algorithm. Thereafter, we had seen a four matrix based upon the fundamental parameters like number of operation, WSDL lines, messages, and operational code lines. So the four service evolution matrices are like this: line per operation, parameter per operation, then message per operation, web service code line per operation. And all these things can be summarized to do service evolution mining, and this will give us four novel parameter which could be written like version 1 having these four parameters, version 2 could have these four parameters, version n could have these four parameters. So this is the service evolution analytics model. Like change mining was being done, evolution mining was being done. Then the analytics tool could be developed in this type of time phases for development phase, for testing phase. Then next output correction, that if software like IDE or testing framework accept such subset WSDL, then it is correct. Human accepted. Then we have seen two types of web service analysis, like for the two self-made web service, two real-world web service analysis, change classification, empirical analysis for regression testing, and then service evolution matrix. So these are the two self-made web service, and changes happen to them. Then we have seen what type of WSDL being constructed. Then we have seen the changes happen to the eucalyptus, different versions of their WSDL, and Amazon Web Service WSDLs. Then we have also seen the test case reduction that could take place for the uh, regression testing of web service for service maintenance. And then service evolution matrix, that Eucalyptus cluster controller and Amazon EC2 for the case study. For these were the actual number of WSDLs, and with the time frame for different number of lines in WSDL parameter and code for the web service and number of operations. So this will help us to generate this type of graph with the help of four service evolution matrices for Amazon Web Service EC2 and Eucalyptus CC. Then in this paper we have seen service change classifier evolution matrix and tool and case study for self-made and well-known cloud services. Then this helped in the maintenance of quality of service and SLA. These were the resources for this research paper. Then other related papers. Then we had seen quality of service and service level agreement for monitoring and resource management. So these are the areas where this QoS is applied. Then we have seen SLA responsibility for the service provided towards consumer, different type of levels of SLAs. Then we have seen web service discussed web service level agreement. SLA contract should contain QS parameter, SLA negotiation, monitoring, violation detection, enforcement, and performance matrices we have seen like turnaround time, total resolution time, mean time to recover, and network uptime, power uptime. So these all majorly have mathematical formulas for different field, different formula. Then we have seen consumer self-provisioning, three different type of provisioning, like consumer self-provisioning, advanced provisioning, dynamic provisioning for resource management and provisioning purpose. So provisioning and orchestration basically deals with creation, modification, and deletion of resources, and then orchestration of workflow and management of those workloads. Then elasticity we had seen for the provisioning and deprovisioning. We need to avoid over provisioning as well as we need to avoid under provisioning. Then we have seen and discussed monitoring for REST and SOAP, microservices, and internal APIs for the customer, private network, local network, data center, private cloud monitoring. Then API monitoring for the whole life cycle of the service for detection of bugs, fixing bugs, and continuous development, deployment, and IT operations. Then we have seen a monitor for SOAP based web service, which is being provided by SOAP UI. Then we have seen advantage of monitoring like prevents failure in advance, verify that service invocation, then triggering for recovery of the failures. Then we have seen QoS and SLA for testing the guarantee of SLA, and for monitoring the we have to do QoS maintenance. So QoS basically maintained by monitoring and testing was being done to guarantee the SLA. We have seen different stakeholders for having different level of testing, like different level of testing, having service functional testing, service non-functional testing, integration and regression testing. Then we have seen web service interoperability standard and protocol for communicating messages between web services. Then we have seen service maintenance, scope, quality, and responsibility of provider towards consumer for maintaining QoS, and change analysis helps to do regression testing that further helps to maintain the SLA. Interoperational and interoperation intra and interoperational change analysis actually helps to do regression testing, which further helps to do maintaining QoS and SLA analysis. Then we have seen reduction in the effort of regression testing helps to do reduce monitoring and maintenance cost for the QoS, and effort reduction in the guarantee of the SLA. Then compositioning of the service could also be satisfied and made available. Then the service monitoring actually helps in the service provider that it should not violate some SLA for the incorrect changes. So this type of QoS monitoring should be required continuous basis, and this was being actually done with the help of reduced regression testing and reduced the effort for maintaining the monitoring and guaranteeing the QoS and SLA. Thus, it saves the cost for the project. And this was it for the this session. These references and reference links. And thanks for the revision. See you in the next class.